Well, 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 students. Welcome to Algebra 1 and welcome to video learning. How fun is this? My voice is in the computer speaking out to you. Today we're gonna just jump right in on something you've probably heard a bazillion times before, which is order of operations. Yay! Did you learn this last year? Yup. Did you learn it in 3rd grade? Yup. But how many of you forgot it over the summer? Let's find out. The essential question for today is, how do I use order of operation to simplify expressions? When I say simplify expressions, I mean something like this. Your book is going to tell you evaluate the expression, and what they mean is basically do it, like just do it, solve the problem. Now, for those of you that didn't remember any math over the summer, which hopefully is none of you, but let's be honest, it might be some of you, what we need to do is we need to just jump right into this problem. And you're probably thinking to yourself, oh yeah, 27 divided by 3, sweet, that's 9. Okay, then I gotta square it, nice, like 81, because 9 times 9 is 81, then I'm gonna go times 2 minus 3, 81 times 2, yeah, that's 162, minus 3, oh, that's 159. I am awesome. But you're not. As it turns out, we're not allowed to just barge in and do things from left to right like that. We have to work in a very specific order, and that's what order of operations is. You need to work in a very specific order. If you started copying any of that down, erase it. That was the wrong way to do it. You can't just work from left to right. What you have to do is you have to obey everybody's favorite word, PEMDAS. PEMDAS. Each letter stands for something. Each letter is an order of operation. It's an operation that you have to do in order. So, let's start with the P. What does P stand for? It stands for parentheses. So if I see any parentheses in my problem, I need to start there. Do we see any parentheses in the problem? No. So we've already done the P because there was no P. Let's move on to the E, which stands for exponent. Do we see an exponent in the problem? Yes, we do. We see 3 squared. That's an exponent. Remember that little number right there? That guy's an exponent. Isn't he cute? Yeah, he's adorable. He's an exponent. So let's do that first. We're going to forget about everything else and just do 3 squared, which is, let's see, 3 squared means 3 times 3, which is 9. Remember, the little number tells you how many times to multiply the big number times itself. So in this case, I multiplied 3 by itself twice. All right, sweet. Do we see any other exponents? No. So like the good student you are, you're going to copy everything else because that helps you stay organized. Next, these two, we're done with exponents. The next two come as a pair. It is multiply, the M, and divide, the D. We treat these as a pair moving left to right. So as I'm going left to right, I'm going to do any multiplication and division in the order that I see it. So first of all, the very first operation I see is 27 divided by 9. That's a multiply or divide. And 27 divided by 9 is 3. And again, I'm going to copy the whole rest of the problem. Now, I'm still in the multiply or divide stage, so I still need to look to see if there's multiplication or division. And obviously, there's multiplication. So I'm going to do 3 times 2, that's 6. Last, I'm left with subtraction. That's no longer a multiplication or division, which tells me I need to move on to the A and the S. And obviously, the A is addition. The S is subtraction. They also come as a pair, meaning as I move from left to right, I'm going to do all the addition and subtraction that I see. In this case, I see 6 minus 3, just the minus, so my final answer is 3. Wonderful. Let's move on to example number 2. Now, what I'd like you to do is I'd like you to pause the video for just a second and just get to start doing this one. Probably you remember what to do. So go ahead and pause your video, try it. All right, did you have some success with that? Let's see. Remember, I am not just barging in and going left to right. I am following PEMDAS. So first, parentheses. I see a lot of parentheses in this problem. In fact, I see two pairs. Here's a pair. They're kind of like brackets. And here's a pair. They're just straight up parentheses. Remember, when you have multiple sets of parentheses, you need to work from the inside out. In this case, these two parentheses are inside of the other two parentheses. So I'm going to start with those. So again, copy the entire problem except for 9 plus 3, which is 12. So 9 plus 3 is 12. I'm going to copy the rest of the problem exactly as it is. Awesome. Now I have another set of parentheses. My second set of parentheses is 12 divided by 4. So I'm going to do 12 divided by 4. That's 3. I'm going to leave the brackets there this time. So inside the parentheses are 3 inside the brackets. Hopefully you remember what happens if you have two numbers next to each other where there's nothing in between. In that case, it means to multiply. And since multiplying is the only thing left, since I killed all my parentheses, since I clearly don't have exponents, now I'm at the multiplication stage. I'm going to go 2 times 3, which is 6. Did you get it right? If so, give yourself just a little pat on the back, you great student, you. Moving on, example number 3. Oh, now, don't get too freaked out, because if you're freaking out now, you're probably going to hate this class. In algebra, we have lots of times where there are x's. It's kind of what algebra is, right? Solving for the unknown. In this case, they're telling us still to evaluate the expression, which, remember, just kind of means do it, right? Like solve it. But for this example, I want to evaluate it when x equals 4. So what that's telling me to do is it's telling me literally every time you see an x, what you can do is replace it with 4. And I'd recommend doing that in parentheses. Here's what I mean by that. When I'm looking at this problem, I see an x. And I'm going to replace it with 4. So when I do that, remember, copy the whole rest of the problem. I'm going to put that in parentheses, that 4. Do you see how the problem is exactly the same, except now I have a 4 there instead of an x? And now I can solve the problem. Remember, we're not just moving left to right. We're using PEMDAS. Do we see any parentheses? Yes, we do see these. But is everything inside the parentheses done? Yeah, there's just a 4 in there. So parentheses are done. There's nothing to do inside the parentheses. Next is the exponent. So I need to look at what is right next to the exponent. In this case, just the 4 is next to the exponent. So I need to, again, copy the whole rest of the problem. What is 4 squared? Well, that would be 4 times 4. That's 16. What operation do I put in between these two numbers, the 3 and the 16? Remember, if there's nothing in between them here, then it's implied that it's multiplication. Awesome. Do we see any more exponents? No. So next I'm going to move to the multiply and divide. I do see multiplication. 3 times 16 happens to be 48. Did you remember that one over the summer? Got your multiplication skills down? Hope so. Finally, I have addition and subtraction. 5 plus 48 is 53. Done. All right, we only have one last problem, and then your first ever video in math class is done. Here's another one where I have m equals 3. Remember, that means everywhere I see an m, I can put a 3, and I want to get you used to doing that in parentheses. So we're going to rewrite this whole thing, but instead of an m, everywhere I see that, I'm going to write a 3, and we're doing it in parentheses. Now, notice I just replaced every m with a 3. Perfect. Also notice I have a fraction bar now. That's kind of annoying, right? Remember fractions? Remember how much you loved fractions? Did you think about fractions over the summer? Probably not. When you're doing order of operations, fractions kind of work like parentheses. And here's how. you want to do the entire top of the fraction, the numerator, if you remember the word for it, separately from the entire bottom of the fraction. Kind of treat them like they're parentheses. You want to do the entire top, you want to do the entire bottom. So let's worry about doing the top right now. I'll kind of do the work over to the side here. On the top, remember I'm still following PEMDAS. Do you notice how I wrote it down each time? A lot of students like to do that to remind themselves. On the top, I do have parentheses, but everything inside them is done. I do have an exponent, so I need to do that now. 3 cubed, 3 to the third. Remember, that means I'm going to do 3 times itself 3 times. 3 times 3 times 3, which is 27. And then I'm going to subtract 21. On the bottom, let's do the first step. Actually, let's keep going with the top. On the top, I just have 27 minus 21. There's just subtraction up there. 27 minus 21 is 6. Done. Now let's do the bottom. On the bottom, do I have parentheses? Yes, but again, there's nothing in there to be done. Do I have exponents? No. Do I have multiplication or division? Yes. Remember, between this 2 and this 3, there's a mysteriously hidden multiplication sign. 2 times 3 is 6. And now I can do the addition. 6 plus 18 is 24. Nice. So I see how I did the top and the bottom totally separately. Now, this is going to give you problems, maybe, unless you were a fraction pro, which I hope you were. Fractions really aren't that bad if you know how to work with them. Whenever I have a fraction, I can leave it as a fraction. I just need to make sure I reduce that fraction. Remember, reducing the fraction means I'm going to look to see if I can divide the top and the bottom by the same number. Just take a second to think about that. What can you divide the 6 and the 24 by? What can you divide the 6 and the 24 by? So I can divide both of those by 6. I can divide the top by 6. 6 divided by 6 is 1. I can also divide the bottom by 6. 24 divided by 6 is 4. And that is my final answer. 1/4. That's a fully reduced fraction. There's your answer. Summary. You just gotta go with the flow, man. Is that how the kids talk these days? Go, hey bro, go with the flow. And the flow is PEMDAS.